today to our presentation on the 7th edition of UL 268, the UL standard for smoke detectors. We have a couple of points we want to mention before we get started. The first one, this is intended to be a listen-only webinar, and if you have any questions during the webinar at any time or afterward, please feel free to chat them in using the group chat feature. Send any questions or comments that you have. We'll take time at the end of the presentation today to discuss those questions and see if we can't get all of our questions resolved today. So again, thank you for attending. We're very happy to have you with us, and we're grateful that you were able to take the time to join us today for this discussion. So the presentation is called, Why Do We Need the 7th Edition of UL 268? Or the title could be, Why Do We Need the 8th Edition of UL 217? UL 268 is the standard UL standard for smoke detectors. UL 217 is the standard for smoke alarms. Some people may say, well, I don't think I need the 7th edition at all. But the fact is these new editions are coming, and whether we like it or not. So it's good for us to learn a little bit about why UL has decided to create these new standards, what has changed, and what it means for us. What can we expect as a result of these changes? So some definitions a little bit here. Smoke alarms, as you likely know, are the self-contained smoke detection units that are commonly used in homes. They have the alarm horn or alarm sounder all built in, a completely self-contained unit. And smoke alarms fall under the UL 217 standard. Smoke detectors are system-type smokes that connect to a fire alarm control panel. Smoke detectors fall under the UL 268 standard. We're going to focus more on 268 in this presentation, but really the changes that apply to 268 are also applied to 217, as we'll see. The changes that have been made, at least the major changes, apply to both standards equally. So getting started, I think few people would argue that working smoke detectors save lives. This comment here, or quote, is from a report sponsored by the National Fire Protection Association. And in the report, they said the death rate from reported fires in homes that had at least one smoke alarm, one working smoke alarm, the death rate was 40% lower than in homes that had no smoke alarms at all. And that's a good thing, isn't it? Any type of device or equipment that can result in the saving of lives is valuable. And smoke detectors and smoke alarms have proven to be very valuable in the effort to detect and indicate fire emergencies. So this is a good thing. As we have discussed a bit already, one of the most well-known and reputable test laboratories for smoke detector testing and listing is UL, Underwriters Laboratories. Now, the first UL 268 standard was created in 1976. Well, that was some time ago. A lot of things have changed since 1976, have they? As an example here. So to keep up with changing technology and the changing times, UL 268 has changed as well. Now, back in the 1970s was when the first single station smoke detectors and smoke alarms were invented. This quote here is taken from a very well-known internet website. The first single station smoke detector was invented in 1970 and made public the next year. And as you may be able to tell from this picture, this was an ionization type smoke detector. And the cost for these detectors back in the mid-70s was about $125 each. But even in spite of that cost, which was really quite expensive at the time, even in spite of that, these detectors started selling. In fact, they sold hundreds of thousands of them per year. But how effective were they really? Did they really work? That was the question that needed to be answered. And so during the mid-1970s, a series of smoke detector performance tests were done. And this testing is commonly referred to as the Dunes study. It's a very well-known, a very famous test that was done on all types of smoke detectors in common room situations. For example, these pictures sort of illustrate what they did. They set up a series of full-scale residential fire detection tests, and they used furniture and equipment, construction methods and materials. All of that was common to what was used at that time. So that being true, the fabrics were cotton and linen. The materials were mostly wood and natural materials. And what they did was they built and furnished these rooms similar to what we see here. And they installed all different types of manufacturers' smoke detectors in the room. And then they lit a fire, and they observed and measured the performance of the detectors to be able to see how did they work, how quickly did they go into alarm, how long would it take for the fire to grow to a point where you could no longer stay in the room. And this study that they did here produced a lot of valuable information about these things: smoke detector performance, tenability time, and so forth. It produced a lot of good information that was eventually included in the UL 268, 217, and NFPA standards and codes. So this was very useful information. But as the years went by, there was increasing discussion about two big concerns. One of these concerns was the performance of ionization smoke detectors during real world fires. It seems that many times there would be a fire somewhere and the ionization detectors were not performing as well or as quickly as they should have, with very unfortunate consequences as a result. The other concern was unwanted alarms from cooking that would lead people to disabling the smoke detectors. These are two big problems. And as time went by, the discussion grew and grew and grew. In many cases, it was comments and feedback from the public and the media that actually drove this discussion. For example, there were two shows, television shows, that were produced. You can find these on the internet if you want to see them. In the year 2000, a show called Silent Alarms. In the year 2004, a show called Stop the Children Burning. These shows are they're quite dramatic, really, if you have the opportunity to see them. But it really helps to illustrate the level of concern that people were expressing around this time. And so eventually the NFPA technical committees began to sort of pick up on these issues, and they started to take steps to address them, to correct them. For example, in the 2010 edition of NFPA 72 in Annex A, you'll find information regarding the placement of smoke detectors in and near cooking areas. They identified ionization smoke detectors as being more susceptible to cooking nuisance alarms than the photoelectric type. And they also identified what they called a zone of exclusion. This was an area. It says smoke detectors should not be installed within a 10-foot radial distance from stationary or fixed cooking appliances. So they recognized there was a problem with unwanted alarms due to cooking. Smoke detectors were being installed too close to cooking appliances. Perhaps they were using ionization type detectors where photoelectric would have been more suitable for that application. So in 2010, after all this discussion, they started trying to work in some comments to the code to sort of start to address these things. In the 2013 edition of the code, they actually added it to the body of the code. At 29.7.3, it said, effective January 1st, 2019, smoke alarms and smoke detectors used in household fire alarm systems shall be listed for resistance to common nuisance sources. There was a problem. The technical committees realized there was a problem. Clearly, additional investigation needed to be done to identify exactly what was happening. So they set up another set of full-scale fire tests. These were done in the early 2000s, commonly referred to as the Dunes 2 study. And as with the first Dune study, they used equipment and furnishings and construction materials that were commonly available at that time. A lot of things were learned from this new research that they did. For example, if we look here at an excerpt from the report from the Dunes 2 test, all right, we can see what they did. Here's the 1975 tests. And what they did was they did two types of fire. They did a flaming fire and a smoldering fire. And they measured the time, how long it took for the detectors to indicate the alarm condition. But they also measured the tenability time. How long could someone stay in that room before the room became untenable? The smoke and the fire and the heat would overcome them and they would not be able to escape. So in the 1975 tests for flaming fires, the smoke detector would sound the alarm at roughly 146 seconds. That's about 2.5 minutes, okay? So after the fire was going, flaming fire, about 2.5 minutes, the detector would go into alarm. The room became untenable at about 1,036 seconds. That's about little over 17 minutes. So what that means is when the detector went into alarm here at about 2.5 minutes, they had approximately 15 minutes before the room would become so bad that they couldn't get out. They would be trapped in there, probably overcome by the smoke and the fire, and probably would die. So they had 15 minutes to figure out, what was going on, get their family together, get out of the house, the structure, and preserve themselves in that way. And they might have been asleep too. So, if you're asleep, obviously you kind of got to wake up and figure out where you're at and what's going on. So they had 15 minutes to do that. In the case of a smoldering fire, the detectors went into alarm about 1,931 seconds. That's about 32 minutes. But the time to untenable conditions, 4,419 seconds, that's about 41 minutes after the detector indicated or signaled the alarm. So from the time the alarm sounds until the time the room or structure becomes untenable, they have about 41 minutes. That's plenty of time to get the family together, to get out, to call the fire department. They can respond, probably suppress or extinguish the fire before any major damage is even done. So that's good. That's what they found in the 1975 tests. But notice what they found in the new tests. For flaming fires, the detector went into alarm at about 47 seconds. But the time until the room became untenable was 177 seconds, about 3 minutes. What that means is from the time the detector sounded to the time the room became untenable, they had about 2 minutes to get out, 2 minutes and 10 seconds. That's a lot less than what they had here in 1975, okay? They hear the alarm go off, they've got to get together and get out very, very quickly before the fire gets so bad that they're going to be trapped in there. With smoldering fires, the alarm is signaled at 2,042 seconds. That's about 34 minutes. But notice, the room becomes untenable at 35 minutes and 48 seconds. They have less than 2 minutes from the time the detector goes off until the time that the room is untenable. Clearly, the evacuation time, the time to untenable conditions from when the alarm is signaled until the room is unoccupiable, it was dramatically less in these new tests. So what happened? What changed from the 1975 tests to the current tests? Well, this is a quote from a technical note produced by NIST. And in part in this report, they made this comment. They said, escape times in this study were systematically shorter than those found in a similar study conducted in the 1970s. This is related to some combination of faster fire development times for today's products that provide the main fuel sources for fires, such as upholstered furniture and mattresses. But it's also due to different criteria for time to untenable conditions and an improved understanding of the speed and range of threats to tenability. So during that time, from the mid-1970s to this test in the year 2000s, they had some adjustments to how they determined when a room was untenable due to heat and fire and smoke and toxic gases. So that thinking had been adjusted a little bit. Another factor is modern homes on average are larger than homes were in the 1970s. So a larger home means it takes more time to get out. But notice that they also identified this. They identified upholstered furniture and mattresses as being one of the problems that was creating this challenge. And that was an interesting conclusion. At some point later, UL did a test, which you can also watch on the internet. And what they did was they decided to compare a legacy room. We see it here on the left. The legacy room is constructed with wood and natural materials, and the furnishings are the same as those that they would have used in the 1960s or 1970s. Natural fabrics, wood, things like that. The room on the right is the modern room. The modern room is constructed with modern construction techniques and materials, and it's furnished with modern furnishings that are based on plastics and synthetic fibers and things like that. And what they did is they said, we are going to light a fire in both of these rooms and watch them as the fires develop simultaneously in both rooms. In fact, at the 1 minute mark, you can see in the legacy room here, you can see a little glow of the flame that's been ignited here on the couch. In the modern room, you can't see the flame. There's a plant or something here, but if you look carefully, you can see some smoke already ascending upward in the room. So this is what it looked like at 1 minute. 30 seconds later, it looked like this. The legacy room, you can still see the fire here, and it looks like it's grown a little bit. But in the modern room, the fire has grown substantially in 30 seconds. And take a look here at the smoke layer interface, this dark smoke layer that's developing here at the top of the room. This is developing very, very quickly. And if you look at this lamp and you look at the top of the lamp right there, and you look at the bottom of the smoke layer interface, notice how this appears 45 seconds later. Here's our fire in the legacy room. It's still glowing, it's still burning, but look at the modern room and look at how quickly the dark smoke is descending and filling up that room. It appears at this point that the fire might be kind of branching out, possibly getting to the curtains and other materials there in the room. 30 seconds later, it looks like this. This fire has definitely grown and spread, and it's growing very quickly. And the black smoke has filled that room to a point where it's now actually spilling out of the room. About 40 seconds later, we have this. The legacy room, fire's still burning, and it has grown, but compare that to the modern room. This modern room is completely untenable at this point, and flashover occurred shortly after this. So there definitely is a difference. This test shows it very, very clearly, where anyone can see this modern room with modern furnishings based on synthetic materials burns much more quickly. The smoke comes much more quickly, much darker. There definitely is a change. And this is what had been leading up to all this discussion with people and the media saying these detectors are not working right. They're not working fast enough. Well, the fuel for the fire had changed. And if you have the opportunity to watch this video, it's really quite revealing, a little frightening. This legacy room flashover occurred about 30 minutes into the fire, about 10 times longer than the modern room. This quote is from a UL report. UL's the one who sponsored that test. And in the report, they said, escape times in a home have decreased from approximately 17 minutes to approximately 3 minutes over the past 40 years due to changes in materials and floor plans in modern homes. So this is a problem, and it's been clearly identified here that there is a problem. But there's the second problem too, the second problem of unwanted alarms from cooking, you'll recall. There was a survey done, the Smoke Detector Operability Survey, conducted by the U.S. Consumer Product Safety Commission. They reported that about 1/2 of the 1,012 respondents had indicated that they had experienced nuisance alarms, with 80% of those attributed to cooking activities. The survey also reported that of the alarms with missing or disconnected batteries or disconnected AC power, more than 1/3 of the respondents indicated that power was removed due to nuisance alarms. When they're cooking food, the detectors go into alarm and they get tired of it and they disconnect them. And a smoke detector with no power or no battery is about as worthless as no detector at all. And you can see this chart showing that smoke alarm activations result for the greatest amount of causes. Cooking far and away is the largest issue there. So smoke detectors needed to be more effective at detecting fire in modern furnishing materials, but they also needed to be better at resisting nuisance alarms from cooking. So now that the problems have been clearly identified, UL formed two task groups. One, to consider how to approach cooking nuisance alarms, and a second one, to develop new flaming and smoldering fire tests using polyurethane foam. Now, if we look here at this table, also taken from one of the reports associated with this testing, you'll see that mattresses and upholstered furniture commonly use polyurethane foam as a base material. Polyurethane foam is widely used in homes and commercial buildings throughout. And the flaming and smoldering characteristics of these products are very unique, and they were very difficult to detect with the detectors that were available at that time. When UL was investigating to find the correct material to use for these new tests, they tested different types of products, different wood, Class B fuels, polyurethane foam, things like that. And you'll notice while they were doing this investigation to identify the right fuel to use for these tests, in this test where they did flaming polyurethane foam, this detector never went into alarm during the time of the test. And for the smoldering tests, the ionization type detector never alarmed in many of the tests. So clearly the polyurethane foam was a very challenging fire to detect. And you know, even when it did detect it, take a look at this. The smoldering polyurethane foam fire in this test, the photoelectric detector did indicate an alarm after 3,032 seconds. But you may remember that the time to untenable conditions for a smoldering fire is 2,148 seconds. So if this room becomes untenable at 2,148 seconds, and the alarm doesn't go off until 3,000 seconds, anyone in that room is going to be overcome by smoke and fumes and gases, and they're not going to make it out. So even though this detector did alarm, it's alarming far too slow. Okay. So UL settled on the polyurethane foam. Again, it produces smoke that is different in particle size and count than the other UL 217 test materials. So they knew that they needed to update the UL standards to include testing for fire in polyurethane foam. And that is exactly what they set out to do. However, there is still the question of unwanted alarms. When they make the detectors better able to pick up this flaming and smoldering polyurethane foam, is that going to make the detectors have an increase in nuisance alarms from cooking? You see, the detectors not only need to be able to detect flaming and smoldering fire in furnishings, but they must also resist common nuisance alarms that may result when cooking. So they had identified this flaming and smoldering polyurethane foam fire after a lot of testing and investigation. UL also established what they call a broiling hamburger test. And this was determined to be the best repeatable test to cover a lot of different cooking scenarios. They tested other foods like toast and bacon and pizza and different things, but the broiling hamburger test proved to be the most challenging of all of the different tests that they performed. One of the reasons why this test is so difficult is that among the criteria to pass the test is this: detectors must not alarm below 1.5% per foot obscuration. That is challenging because at 1.5% per foot obscuration, you do have smoke. But for this test, in order to pass this test, the detectors must ignore the smoke from this cooking of this frozen hamburger. It must ignore that until it reaches 1.5% per foot. So at the time, with the detectors that were available when these tests were established, research indicated that very few, if any, of the smoke detectors would be able to pass those tests, the PU foam and the broiling hamburger test. And yet at the same time, studies recognized that an across-the-board increase to the level of performance specified in these UL standards would significantly improve the overall performance of smoke alarms by expanding the range of fire scenarios alarms must respond to while requiring resistance to nuisance alarms. So they understood if they can include these tests and perform these tests on smoke detectors and smoke alarms, the result is going to be a much better and much safer product. And so the next step was clear: develop new standards and include these tests for PU foam and for the broiling hamburger test. Well, this is great news for the public, right? Because smoke detectors and smoke alarms will have a much better performance, and better performance means greater safety for everyone. But this also meant that the manufacturers of smoke detectors needed to get to work. UL established a deadline, and when the deadline was reached, all listed smoke detectors must meet the requirements of the new standard. And this applies to the 7th edition of UL 268 and the 8th edition of UL 217. Okay, well, we've explained, discussed why these changes were made and the benefit that will come from it. The question now you may be asking is, what does this mean for me? Well, the UL compliance date for the 7th edition of 268 and the 8th edition of 217 is June the 30th, 2021. What that means is that smoke detector manufacturers can no longer produce and label smoke detectors as being UL listed unless they have been tested and approved to these standards. So after June the 30th, 2021, all the detector manufacturers will be listing their detectors to these standards. They can no longer manufacture them and label them to the previous standards. Okay, well, you may still be asking what does this really mean for me? I'm not a smoke detector manufacturer. I install smoke detectors, or I design systems, or I do service and maintenance work on systems. Well, it's going to be a sort of a natural progression, I think, because as detectors are unable to manufacture and label detectors to the previous UL standards, they're going to start to manufacture the new detectors. And when you purchase detectors, the new detectors are what you're going to get. So it's going to be a natural progression over to the new detectors that comply with the new standards. However, the 2019 edition of NFPA 72 also has a couple of comments that help us to see that it will be an enforceable thing as well. In Chapter 2, Section 2.1, it says, the documents or portions thereof listed in this chapter are referenced within this code and shall be considered part of the requirements of this document. And two of the documents listed here that are considered to be a part of NFPA 72, UL 217 8th edition, UL 268 7th edition. So for those areas and jurisdictions that are using the 2019 edition of NFPA 72, then they naturally have reference to these standards. And if you're installing systems to the 2019 edition of 72, then you would really be required to use detectors listed to those standards as well. In Chapter 29, 29.11.3.4, Item 6, it says effective January 1st, 2022, smoke detectors and smoke alarms installed between 6 feet and 20 feet along a horizontal flow path from a stationary or fixed cooking appliance shall be listed for resistance to common nuisance sources from cooking. That means 8th edition 217, 7th edition 268. So there will be a natural change as the manufacturers start making these new detectors, but there will also come a time where it will be a requirement to provide these new detectors with new systems as well. Well, how has Hochiki responded to the UL 268 7th edition challenge? As you likely know, Hochiki is a well-respected leader in the fire protection industry. Founded in 1918 in Tokyo, Japan, Hochiki has designed, manufactured, and provided smoke detectors to their own customers and also to many industry-leading OEM alarm manufacturers as well. As soon as the news broke of the new editions of the UL standards, Hochiki's smoke detector engineering team got to work to design new detectors that would meet the enhanced requirements of these updated standards. And conventional and analog addressable detectors have already been designed and have already passed all of the preliminary tests at UL for the updated requirements. So these new detectors will not only comply with these expanded requirements and these new tests that UL is requiring, but these detectors will maintain the high level of quality and reliability that is associated with the name Hochiki. So to summarize our presentation here today, the updated UL requirements for smoke detectors represent a major advance in the performance and stability of UL-listed smoke detectors. We talked about the danger of flaming and smoldering polyurethane foam fires, how quickly they grow, and how challenging it is for older type detectors to be able to detect and indicate those alarms. We talked about the challenge of unwanted alarms from cooking. The new UL standards have taken big steps to correct those matters and provide all of us with better, more reliable detectors. And everyone is going to benefit. The end users will benefit from better detection in all types of fires and furnishings. AHJs, installation companies, and end users will benefit from less unwanted alarms due to cooking as well. So these changes to UL 268 is something that the fire alarm industry can feel good about. Now, Hochiki is ready to support you with questions about UL updates, system design, and product application. With over 100 years of experience in the fire alarm and life safety business, Hochiki is uniquely qualified to support you with any and all fire alarm and life safety projects, questions, and concerns. So we're happy to be able to present this information to you today. Our contact information is here on this slide, and hopefully this will help you not only to be able to understand why these changes are coming, but so that you can tell others and help them, your customers maybe, or maybe fire authorities or other people, to help them to see the reason for the change and how everyone is going to benefit from it. A lot of times it's challenging and difficult to accept changes. You know, we get used to certain products and certain things being the way that they are. But in this case, this is going to be a very good thing for everyone. And we want to spread the word so that everyone can understand and feel good about what's happening here. So thank you very much for your attention. If you do have any questions about the presentation, about Hochiki products, if you have any application questions or anything of that sort, please do feel free to contact us at these links, using these links here. Obviously, we are here and we're ready to help you in whatever way we can. I'd like to take the opportunity to thank all of you for attending today and for your support of our company and our products. We appreciate that very much. We really want to work with you and to help you be successful for your company and for your customers as well. The work that all of you do is a very important work. You are involved in saving people's lives, and that has real meaning. And I hope that all of you can remember that and feel good about what you do, because you provide a very, very valuable service. And thank you for that. So I appreciate your time again. On behalf of Hochiki Asia Pacific, I want to thank you and hope that you have a wonderful afternoon. And I hope to see you again on a future webinar. We'll be having more. Look for that on the Hochiki Asia Pacific website. Thanks again and have a good day.